You buy a multi-$1,000 workstation. You max out the specifications to 64 gigabytes of memory. And yet, when you click a basic desktop menu, the system hesitates under the weight. It physically lags. Computer science recognized this inevitability decades ago. It's known as Wirth's law, the principle that software speed decreases more rapidly than hardware speed increases. Today, a simple to-do list application easily consumes 500 megabytes of memory. Developers achieve speed to market by packaging entire web browsers inside desktop wrappers, prioritizing convenience over efficiency. Compare that to the original Windows Task Manager, written by Dave Plummer in 1995. That entire utility was engineered to run flawlessly within a footprint of less than 80 kilobytes. Plummer designed the Task Manager as a digital life raft, forcing it to remain functional even when the rest of the operating system was completely frozen, gasping for available memory. Modern sluggishness represents a structural abandonment of the instinct for refusal, the engineering discipline that once made software virtually indestructible. In the early days of MS-DOS, systems were bound by a strict 640 kilobyte memory wall, and software was physically stamped onto low-capacity floppy disks. To survive in that environment, Microsoft engineers in the 1990s kept physical stopwatches on their desks. They manually timed scroll speeds, boot sequences, and file saves to the millisecond. Every line of code was measured against strict physical reality. Raw speed did not always translate to user satisfaction. When Microsoft released Visual C++ 1.0, the compiler was mathematically faster than its predecessor, yet developers complained that it felt sluggish. This animated diagram illustrates how Steven Sinofsky solves the problem. By adding a spinning progress wheel of random numbers, he introduced a CPU-intensive process that technically slowed the compilation down. Yet, the continuous visual feedback tricked the user's brain into perceiving rapid progress. In the era of scarcity, true performance required a deliberate, psychological negotiation between machine constraints and human expectation. Dave Plummer applied this strict discipline when building the Task Manager. He enforced a hot path rule, where every variable and memory allocation had to literally fight for its right to exist in the main execution line. He bypassed the standard C runtime initialization entirely. Stripping away the massive boilerplate payload, Plummer launched a sleek 80 kilobyte life raft. It didn't ask the struggling OS for running programs. Instead, it shot direct queries to interrogate and terminate locked software without the central hub. That intense focus on efficiency evaporated as memory and processing power became abundant. The economic incentives of the tech industry shifted entirely. Spending months optimizing code became a financial liability, while shipping unoptimized features at maximum velocity became the standard. The career of the Task Manager's creator reflects this exact industry shift. Dave Plummer eventually left his disciplined role at Microsoft to found a commercial venture called softwareonline.com. In 2006, the Washington State Attorney General's office filed a formal consumer protection lawsuit against the company. The state prosecuted Plummer's firm for distributing deceptive registry cleaners, citing the use of fake scans and persistent adware to drive sales. The engineer who crafted the ultimate system recovery tool was fined for selling software that extracted wealth by slowing down user machines. It is a precise mirror for the broader tech industry, a slide away from rigorous space-constraint engineering towards chaotic, bloated commercial extraction. Fast forward to the present. The abandonment of the instinct for refusal is now actively breaking our most advanced developer tools. The massive, unoptimized code bases we accept as normal are overwhelming generative AI. The primary threat is semantic entropy. Automated AI agents rapidly generate redundant logic and duplicate branches, tangling the software architecture. This uncontrolled multiplication maxes out LLM token context windows. Coding assistants hit this hard limit and fail entirely. Abstract digital waste exacts a massive physical toll on global infrastructure. Wrapping desktop utilities in heavy web browsers forces processors to spin up continuously. That tiny, constant tax across billions of devices forces massive data centers to consume millions of gallons of evaporative water and gigawatts of power just to keep pace. Reclaiming software discipline serves as a direct lever to reduce global resource consumption, preventing our digital infrastructure from collapsing under its own bloat.